Violin memory to talk about Flash. So the first start is really why are people looking at Flash? And the focus is really that real-time data access is what's driving the transformation of the data center. All of the applications, they need to run faster. Really, it's about getting results in human speed. If I can wait for days or many hours for my results, it's a very different problem than if somebody's waiting for an answer. Seismic, if somebody's waiting to see traversing through data through a changing coordinate systems or looking through different planes, they don't want to sit there waiting for hours. If I'm doing big data, a lot of times I need a result fast across a lot of information. Where Flash is coming in is bridging the gap between DRAM and spinning disk. So you've probably seen these curves. Moore's Law has been doing a great job for server compute for a long time. And admittedly, we may be slowing down on Moore's Law, but we're still, each server complex has been getting faster and faster for decades. And a really nice curve. Now the networking folks, they haven't been doing as great for a while, but currently they're getting better faster than compute is. So they're actually, networking speed is going up at a faster curve. But still, it's going at a really nice clip. But storage performance really leveled out about 12 years ago. When we hit 15K RPM drives, we started focusing on aerial density and capacity, but performance per terabyte has been going down steadily for a decade, maybe 15 years. If these three things aren't balanced, your applications don't run any faster. If I can't get data into the server, the application doesn't go any faster. Whether it's a network bottleneck or a storage bottleneck, it doesn't matter. Throwing more compute when you can't get the data in there, nothing gets any better. So really what you've seen it growing in these I/O-intensive applications is that the effective idle time, I/O wait times just keep growing. If we upgrade our compute from Sandy Bridge to Ivy Bridge, your goal is not to get your idle time, your I/O wait times from 50% to 80%. You need the data to get into the server. And really that's what our company is all about. So what we focus on is, you may have heard everybody talks about IOPS in Flash, because in SSDs. Well, IOPS only matter up to a certain point. If you've had tens of thousands of something and now you have tens of millions, that's probably not your problem anymore. But latency is the real problem. Because latency is how long I'm waiting for the data to get into the processor. Now if I can solve that problem of latency, I can increase my performance by a large factor. These are measured numbers. We get customers somewhere between, sometimes they're 40 times faster. It's all about keeping those processors fed with data. You can also reduce the amount of storage. Because for a long time, the way we were getting around the limitations of disks is we were short stroking. We're putting, imagine you had a 4 terabyte database. Well, I could potentially store that in one spinning disk. But I wouldn't do that because one disk doesn't have enough performance, enough throughput to satisfy any application. So we would use hundreds of disks, even if we only needed 4 terabytes. If I use Flash, it's fast enough that I can just allocate the storage that I need for my application. I don't have to over-provision. Even more is, if my servers stop waiting for I/O, I need less of them. If I spend 80% of my time waiting for data, and I cut that down to basically 0, because the latency is going to 0, then I need a lot less servers. Each core gets to do more work per unit time. This results in more efficient servers, less power, less space, less cooling, all of that. In fact, another nice thing is it's also less software licenses. If I had to buy, for some database, a whole bunch of server licenses because I was feeding, it was working around the I/O latency problem. If I get each server to do more work per unit time, and I have less servers, then I need less licenses to cover those servers. In fact, that often pays for a much more expensive storage system, even more than we can charge you would be saved, just from the software licenses. So, as a company, we started out with memory arrays. We've been shipping these for about 4.5 years. We're actually in our 4th generation. This is the system you use for storage on the network. SAN connected, it could be iSCSI, it could be fiber channel, or if you want to be really fast, you can use InfiniBand. This is where you in the past might have used a big EMC, Hitachi, IBM. big iron systems for mission critical applications. This is for the applications that can't go down. So the design was all about no single points of failure, everything being hot swappable. More importantly, no performance changes under failure. So like I could pull out 3 out of 4 RAID controllers and still run at 500,000 IOPS on a box this big. And more importantly, the latency didn't change even though I ripped out 75% of the hardware. Remember, it's all about latency at the end of the day. Very few of our customers use the million IOPS we have in every box, but everybody cares about the latency. Now we also know that not everybody needs an array. Not every application is designed for that. A lot of applications are scale out, where they want the storage in the server, so they can scale as they scale servers, they scale their storage performance. So we've taken our same low latency technology from the arrays and put it in a PCIe form factor. And for this, the goal is, again, a flat, consistent latency curve, no spikes, no right cliffs. If you've ever used SSDs where you look at the latency and it looks like a heartbeat, ours is a flat curve. So you designed a predictable, flat latency curve. We did the same thing in the arrays that we did in the cards. So that's another focus for applications where it just works better to have a direct attached storage model. Additionally, we also know that if you just bought a spinning disk array and you just want it to run faster, you have a couple choices. You could buy a shelf of SSDs, which is really expensive and it doesn't necessarily make everything a lot faster. So we acquired a company called Gridiron, which does memory appliances. So think of this as a transparent bump in the wire. It's transparent to plug in and transparent to come out. But what it does is it actually accelerates any spinning disk system with flash on the network. And it's extremely efficient cache, where you might be used to, like EMC, caching in 40 megabyte chunks. We cache in 4K. So it's 10,000 times as efficient in use of flash. Just imagine a box you could put on the network that would make even an old legacy array have somewhere between 20 and 500 microseconds of latency. And if you ever change your mind, you can just pull it out, and the applications and the servers all they see is a performance change. There's no changes to the application, no changes to worldwide names. So it's truly transparent. Finally, none of this would be any good if you couldn't manage it. We have customers like AOL who have more than 2 petabytes on the floor. Managing hundreds of systems is really hard. So we've made a system where literally you can manage your entire environment from an iPad or an iPhone or an Android phone or any web browser. And you can do management at scale. Everything from saying, I want to define a class of storage that's Bill. This is what Bill uses. I want to report if Bill is ever going to have a bad performance day and send an alert so I get a warrant before Bill calls me up. In fact, you can even put Bill's phone number in the LUN so you know who's going to be calling you. All of this software will manage all our cards, all our arrays, and our memory appliances, all from a single point. So we've been selling for about 4.5 years. The company was actually founded in 2005. We have hundreds and hundreds of customers, all from the big government. We have like 24 telcos now. A lot of the Wall Street and London banks. So really, we've been in mission-critical environments all over the place. And one last news, since we're actually also in the Microsoft booth, is Windows 2012 was actually designed on Violin. So Microsoft used our system to actually tune out the latencies in Windows. So one of the things we work with them on is we have these stateless x86 controllers inside there. Well, why not just put Windows directly inside the array? So you can turn our array into a 3U fault-tolerant Windows file server just by changing this, downloading Windows storage server. So that turns us into a file server that scales out horizontally and has all the latest features of CIFS and NFS and iSCSI and everything else. What I like about this is one of the great things about the new version of CIFS is it has DMA support directly in the file server. So I can actually do a read from Flash and DMA it over a network directly into the application buffer without going through CPU. With the goal of that is to effectively make file servers be as fast as block. Once you get the latencies down far enough, file servers are a lot easier to manage than a block server. And this actually does scale out horizontally. So that's actually something we have a demo on at the Microsoft booth. Really the vision of the company is we want to remove the last bottleneck in the data center. We're doing really well on CPU, we're doing really well on networking, like Mellanox keeps driving the performance up. But if you don't improve the speed of storage, more importantly the latency of storage, nothing gets any better. Thank you. So anybody have any questions? Yes?